can use those ratios if it's a right triangle. All right. You see number one, I'm looking for side x, but unfortunately I don't have enough information for Pythagorean theorem. So I am going to have to rely on the sine, cosine, or tangent ratios. But that board won't be down in Gym B, obviously. So if you're going to use SOHCAHTOA, make sure you know how to spell it. All right, by that Wednesday. So let's go here. Going from the 30 degrees, I need to know what sides I have, opposite, adjacent, or hypotenuse. So let's start this off. Jonathan, what is the x to the 30? Adjacent. That is adjacent, and the 24 is? All right, so everyone, I have adjacent and hypotenuse. That only allows me to use one of the three ratios. And which one does it allow me to use if I have those there? Taylor? Cosine. Good job. So let's review again how to set this up. Cosine, abbreviated COS. Then I put the angle I'm using, which is always the non-right angle there, 30 degrees. And I set that equal to the ratio, adjacent over hypotenuse, CAH. So adjacent x, 24 hypotenuse. Everybody all right on the setup? How to solve it? I always had you guys put that sine, cosine, tangent over 1, and now we cross multiply. And that is why you need to be in degree mode. I will probably, most likely, you'll be reminded, because I'm not going to do it for you. I have 80 plus students that are going to be taking this Regents, and I'm not going to be putting 80 plus numworks into degree mode. So you guys can do that when you get into Gym B. Cross multiply, we're rounding to the nearest whole number here. Nearest whole number. Choom, halo, nearest whole number when you have it. What do you have written down on your paper?
Or I accented tan.
21. Everyone all right? 21. And also, too, I'm pretty confident. I didn't check, though, but if you use sine or tangent, I'm sure that answer's there, too. All right, so more traps for you. All right, more traps to make you feel comfortable. That's finding a side. Now we'll review finding an angle. Okay, how do I find an angle using sine, cosine, or tangent? So I need to find angle A. Same questions for somebody. What's the 9 and the 14? Opposite, adjacent, hypotenuse, so I know which ratio to use. Going from angle A, here we go, Mia. What is the 9? And the 14? Good job. So it looks like, which ratio once again here, Sydney? Cosine. So, all right, ready? Nothing has changed, right? Like how we found a side until now. So I'm going to say cosine. I don't have an angle. I'm going to just say A because that's the angle I'm looking for. Adjacent over hypotenuse. We do not cross multiply when we find an angle. We do not put this. If you try to put that over 1 and cross multiply, I'm not too sure where it's going to lead you to on the calculator. So we do not cross multiply on the calculator when finding an angle. Instead, I should have my numworks already up here. Instead, what we're going to use anytime we need to find an angle, the arc buttons. Okay, the ones that are in yellow here above sine, cosine, and tangent. That is what we're going to use anytime you need to find an angle in a right triangle. So angle A, we're going to do arc, cosine, and your calculator is going to ask you to put in a fraction. We're going to put in that ratio 9 over 14. So just a reminder how we find an angle using sine, cosine, and tangent. So just a little reminder there. And nearest degree when you have that. Nearest degree, Keating, when you have it. 50 degrees. And this is all the time we have to review this, right? And so it's finding a side versus finding an angle. Questions there? I'm actually going to skip over to number 4. We'll come back to number 3 here, but I'm going to skip over to 4 since we're talking about using sine, cosine, and tangent. All right, you're probably going to see at least one multiple choice. Okay, one multiple choice using sine, cosine, tangent. And confident you're probably going to see a part 3 using sine, cosine, or tangent. All right, a big dog problem. 4-pointer, got to show a lot of work, how to get to it. And it's probably not one step either. It's probably not going to be, oh, I'll just do cosine 30 equals x over 24. There's my answer. It's probably going to be a multi-step one. So this is a previous Regents question. Ended up in the part 3. You guys need to figure out how tall is the tree, TB. How tall is it? Problem though, look at the triangle that has TB as a side. Look at that triangle that has TB as a side. Is it a right triangle? So you're not using sine, cosine, tangent on that. Sorry. It's only for right triangles. Sine, cosine, tangent, only for right triangles. So you cannot use opposite, adjacent, hypotenuse in this triangle. So we're going to have to get the tree's height somewhere else. Okay, we're going to have to get the tree's height somewhere else. And I really don't want to give this away. Everyone see the 50 for the building? I think there's another side that's also 50, right? If I got a rectangle up here. So this side is 50 over here. Which means I think if you can get me to this side right here, I can just subtract it from 50 and we're good to go. All right, so I think that'll be our plan, but I need your help. How do I get to that side, right? How do I get to that side? So I'll let you look it over right now because I'm not going to tell you what to do. I would love that red highlighted side so I could subtract it from 50 and get that tree line. You got a couple angles already. You got a couple right triangles in there too, it looks like. Do you see that this little side that I need here to subtract from 50 is part of this right triangle? Problem is, though, I can't use sine, cosine, or tangent because I don't know another side length. Can you get me another side length, though, of that triangle I just highlighted? I hope so. I hope so. You don't need to use that. We could use, how about this right triangle instead? Let's start with that right triangle. All right, let's start with that one because you can get this side right up here. I'll call it Y. And that'll get you a side in the other small right triangle. So everyone see the plan? I'm going to have to use 2 different right triangles right now. All right, let's use the big one I have highlighted up there to find Y. Which degree measure am I going to use? 22.2 or 13.3? Which one am I going from here? Hayden? The whole one, 22.2. All right, so what's the 50 in the Y? That's my question. Everyone look at 22.2. What's the 50 in the Y? Opposite, adjacent, hypotenuse. Taylor, what's the 50?
The 50 is the opposite.
Opposite, and what about the Y?
Adjacent.
Good job. So Taylor said we have opposite and adjacent. Which ratio do I want now, Rowan? Tangent. Yep. So I'm going to go tan 22.2. Opposite side is 50, we know. And the adjacent side we're trying to find, I'm calling Y. It doesn't have to be Y. It can be whatever variable you want, but. Put it over 1. We're finding a side, right? So we can cross multiply if we're finding a side. And go ahead and cross multiply. A reminder as you guys are calculating this, is that my final answer? Nope, so please write out all the decimals after. And just start reading off what you have here so I know it's correct here. Zoe, what's that side length?
122.52.
Okay, yep, you're good. I don't need you to go all the way there. 122.52, 12599. All right, there's that side. Now use that side in the smaller right triangle. I guess I'm running out of variables, huh? I guess I'll call that Z. Juliana, I don't want to use the 22.2 anymore. What angle do I want to use in this one now? Yep. Everyone see now, no more 22.2. I can use the 13.3. All right, let me ask you guys, Juliana, again. The side I'm trying to find, I labeled it Z, opposite, adjacent, or hypotenuse.
Opposite.
And what about the side we just found? All right, so it's going to be tangent again, but now using 13.3. Opposite side, and now you're using that non-rounded answer as your adjacent side. And just give me a few numbers, what you got for that side. Give me a few numbers there. T, when you're ready.
28.96.
Okay. You're good. Yep. 28.96279.854. And we're almost there now. We needed that side to subtract from 50 to find the tree. All right. And nearest meter, so whole number here. So you subtract that nearest meter for me here. Jackson, 20, 29, 21. All right. Whew. 4-pointer right there. All right, part 3 question. Also, I just want to make it clear too, that's not the only way to do this. I don't know if anybody was thinking maybe there's a right triangle down here. If that's 22.2, alternate interior angles, that's 22.2. You could have found this side and said it was equal to that one. A couple different ways here. Just don't think it's my way or nothing. There's a couple of different ways. All right, all good there? All right, let's go back to number 3 now. A little fact about sine and cosine. I know you guys don't. Let me write it up here. All right, they're asking for the smaller angle up here. And I know most of you probably, without the review, would just set 4x equal to 3x plus 13 and go to town. That's not what we want to do here. Okay, that's not what we want to do here. If those two ratios are ever equal to each other, if those two ratios are ever equal, sine and cosine, the angles are not equal. Anybody remember back in the day what we knew about those angles? Take your calculator right now. Ready? Please type in cosine 20. Cosine 20. You're going to get a decimal. I don't care what it is, but cosine 20. Then do sine of 70. Notice that they're equal. Sine and cosine are equal if what? Anybody's noticed anything about 20 and 70? Well, let's do it one more time then. Ready? And let's do it one more time. Do sine of 10. Sine of 10, and then do cosine of 80. Again, they're equal. What do you notice about 20, 70, 80, 10? Complementary, right? So sine and cosine, those ratios are only equal if the angles are complementary. They add to 90. So that's what I want you to do here. Not set the angles equal. but I need you to add the angles and set them equal to 90. I know it's very, very tempting and easy just to set them equal, but that's not true. Sine and cosine are only equal if the angles add to 90. So go ahead, get a value of x for me. And I got to talk about a big trap that the Regents loves to do to kids. Big trap they love to do. When you have the value of x, Mia, let me know. Yep. Here's the trap. They know you're going to solve for x for this. They know you need x. So what do? They put x as a choice. Pick me, you're a winner. No, you're not. Read the darn problem. We're not looking for x, we're looking for the smaller angle here. So take your 11, substitute it back into both angles, and then tell me what the smaller angle is. All right, huge trap the Regents loves to do. They know you're going to solve for x, you got it. So why not put it as a choice? Because you're going to be going 100 miles an hour. You got nowhere to go other than back to class anyway, so take your time. Plug 11 back in. Let me know when you're ready. Zoe, which one ends up being the smaller angle? 44, got it. Yep, so 44 degrees. Please read carefully. Please read. You do all that great work and you're going to get it wrong. And remember, there's no partial credit. We're not even looking at the multiple choice. So. All right, SOHCAHTOA down. Another monster topic. This was a whole unit. Probably spent 2 months on this unit. Quadrilaterals. I obviously know you don't remember the properties. That's fine. June 11th, though, they're right at the tip of your tongue. All right, so you got to June 11th to know it. If you need a property, here's where it is right now. So as we do these problems, please reference this flow chart here. Here's how it works too. If you take anything in a quadrilateral there, it's covered on everything below it. If you take the parallelogram, it's covered on everything below it. We just didn't write in the properties over and over and over again. Everyone all right on how this flow chart works? If you take one, it's in everything below it. Okay, good? All right, here we go. Speaking of using that flow chart, I have a parallelogram, but I want to go to a rectangle. What's got to happen? Okay, one of those choices will turn a parallelogram into a rectangle. One will turn it into a rhombus. The other two will keep it a parallelogram, but only one will move it into a rectangle. So look at your special rectangle properties there. What's going to move a parallelogram into a rectangle based on that chart? Okay, here we go. Zoe, anything? Diagonals are congruent. That's a special property of a rectangle. Perpendicular makes it a rhombus. The last two here, 3 and 4, just keep it a parallelogram. That's a parallelogram property. Nothing special. All right, speaking of parallelograms, I apologize in advance. I cut off here. This should be bisects ABC, and that vertice up there should be C. 6. Should be bisects ABC, and C is that corner vertice. All right, angle A is 40. Everyone should be putting some markings on your diagram too, because we have an angle being bisected. So we should have arc marks on your angle somewhere. Find the angle that's being cut in half into two congruent parts. We should see arc marks on your diagram. Right here, those two angles are congruent. You have all the properties of a parallelogram right up there to help you, because I know everyone doesn't remember them, and that's fine. I need to go from angle A to BED using properties of a parallel, or any properties of anything. It doesn't just have to be a parallelogram. So here's how I'm going to do this problem. I'm just going to start calling on numbers. You tell me whatever angles you can find now. I'm not expecting anybody to find BED right away. Tell me an angle to fill in that you are confident in. All right, it does not have to be the final answer. I don't expect it to be. Tell me an angle you're confident in here. Here we go. Keating, angle you're confident in.
C is 40.
C is 40. Keating's using the property. Opposite angles are congruent. All right, we'll get to BED eventually. Keep filling in angles you're confident in. That's how I want you to approach these problems. Juliana, another angle you're confident in. Angle D is 140. She's looking up at the properties. Consecutive angles are supplementary. Angles in a row add to 180. All right, let's keep trucking. Other angles you're confident in. I'm going deep on this one here. Izzy? Angle B, all of angle ABC is 140. And can we stop there? It's being cut in half now. So you should be confident in more angles. 70, 70. We're getting there, right? We're getting there. How am I going to get to BED? There's a couple places you could find BED right now, or you could go to BEC. I don't care. Direct us where to go now. Zoe, direct us where to go. You have a triangle on the right that's got 2 angles already filled in. You have a quadrilateral on the left that's got 3 out of the 4 angles already filled in. Which one? The quadrilateral or the triangle? Add all 3 of them up and subtract them from what? 360. Quadrilaterals, all of them add up to 360. And then when you have that, let me know, Zoe, because that's our answer. $110. Yep. All right, everyone good? Guys, you're not going to find the answer right away. Keep putting in different angles you're confident in, and eventually you'll get there. All good? All right, let's keep rolling. Little mini type of proof here. Read through, mark your diagram for me. Read through all the directions, because you might miss something that's important. All right, hopefully you read EF bisects DB. Where are you putting your congruent marks? That's what I want from somebody first. If EF bisects DB, where are my hash marks on this diagram here? Hash marks, Jesse? Good job. DM is congruent to MB. Done. All right, now I need to know which method up here is going to prove EMB and FMD congruent. So this triangle with this one. And it's a parallelogram. All right, Jesse added the congruent marks on for you. What markings can you add on? It's a parallelogram. I see another pair of angles. I don't need to know anything that it's a parallelogram that I can mark congruent. Give me something else you're marking congruent up here other than what Jesse just gave us. Give me some angles up here that are definitely congruent. Jesse, how about some angles? Vertical angles you can mark on your own. Good. We have not even mentioned why it was a parallelogram yet, so hopefully somebody's marking something congruent because it's a parallelogram. And I'm only concerned about, yeah, you could tell me AD congruent to BC. I don't care, though, because they're not in those triangles. Can you see anything else that's got to be congruent in those 2 triangles? Because it's a parallelogram. Anything else congruent because it's a parallelogram? Jayla? And okay, can you get more specific for me? Because there's a bunch of angle Ds and Bs. Yep, perfect. These 2 right there. Those are alternate interior. Parallel lines mean the alternate interior angles are equal. Okay, right now, what method do I have up there right now marked? What's that method to prove triangles congruent right there? Is it? Okay, it's angle side angle because the side's in between. Now everyone's going to rush to circle number 1. Not yet. Not yet. What type of angles are those? Same as Jayla's angles. Those are alternate interior. Plus, even if you didn't notice that they're alternate interior, You already have two pairs of angles congruent in both those triangles, the vertical and the alternate interior Jayla told us about, right? What do all the angles add up to? 180. So shouldn't the remaining angles be congruent too if they add up to 180? That way back in the day, that was called the third angles theorem. So not only do you have angle, side angle, you also have angle, angle, side. All right. Common mistake is everyone finds those first two angles and just picks angle, side, angle. But hey, those are alternate interior too. Those are alternate interior. Anybody remember my trick for alternate interior? Look for what letter? Look for the Z. Hey, there's the Z right there. Eats them up. Eats them up. All right, they're alternate interior. Ooh, baby, you better buckle up for this one. This is a beast, this one. And they're all, by the way, they're all old Regents questions. Trapezoid, yikes. AB parallel to CD. And we also have AD congruent to AE. All right, can you guys fill in those angles for me? Oh boy, this is going to be a beast. 35, 25, 30. Get me to ABD now. Get me to ABD. I'm going to do the same thing I did 2 problems ago. Call on a student, tell me what you're confident in. You have parallel lines, and these two sides are congruent. Give me an angle that you're confident in. Choom, halo, angle you're confident in. ABM, which one?
AEM.
I'm going to find it here. AE, which one?
EM.
AEM. Oh, yep, 30 because they're what? Vertical. All right, we're getting there. I don't care what angle you give me. I want to get, sooner or later, we'll get to ABD. It might take us a couple minutes. I don't care. All right, that's 30. All right, how about another angle somebody's confident in? Juliana, anything you're confident in? Yep, 180 degrees in every triangle. We're moving. At least we're filling in something. We'll eventually get up there to ABD. All right, more angles you're confident in. Anything else you're confident in? Hayden?
65 degrees for BCE.
Which one?
BCE.
BCE. This one here?
Yeah.
How do you know that? It's a trapezoid, not a rectangle. If you're thinking 90 degrees, that's not a property of a trapezoid. Okay? All right, that's on this. I have no idea if that's a right angle or not. Trapezoids don't have right angles, rectangles, and squares. All right? Other angles we're confident in here. Other angles. Halo, anything else? Let me give you a little push. What type of triangle is ADE? Yep. What do you know about isosceles? Not only two sides, but yep, across from them. I already know the one that's not congruent is 35. So the other two have to be congruent to each other. All right, so can you find those? And I think that'll be the push we need here. Yep. That it is. 72.5, 72.5. Whew. We're getting there, kids. We're getting there. Shoom. All right, Maddie. Anywhere else you want to go? DEN. Where's DEN? This one here? How are you getting 77.5 for that one? I think you are right. I just want to know how you got 77.5. Yeah. Hey, everyone see AEC is a straight line. So 72 and a half, the 30, and the one Maddie just gave me, which was what? 77.5? 77.5, they have to add to 180. All right, because straight lines add up to 180. Whew. I'm getting exhausted, I know. We're getting there, though. Halo, anything else? Back to you. That was, yes. Okay, look at these angles we just got here. It looks like I got a couple vertical angles to them on the other side, right? Yep, 72.5, and while we're here, I'll just do 77.5 for the other vertical angle. Whew. All right, we're getting there. We are getting there. We got to start filling out that top a little bit there. Izzy, anything? Here you go. I want you to focus on that angle. What other angle on here? It's got to be 25 then. You got it. Everyone, alternate interior. Okay, alternate interior. And now I'm going to lead you to the promised land. Just so you guys don't get too tired, because I know you are already. Everyone see this triangle right there? How many angles do I know? 25. These two combined, now you can find ABD. Okay, now you can find angle ABD. You could, hey, could we still keep finding more and more angles? Absolutely. But I just wanted this to end. I just wanted it to end. All right, how about that angle here so we can finish this bad boy off here. Keating, when you have it.
47.5.
47.5 degrees. Don't give up. Just keep finding angles. Don't give up. Keep finding angles. All right, all good? All right, that took a little bit longer than I thought, but it's fine. All right, next up, what's enough to prove ABCD is a parallelogram? Which information is enough? Let me go through each choice. Choice one, everyone look at it. If you know, please don't mark this because it's going to get messy. What type of angles are those? Corresponding. Can you find what lines have to be parallel now? If 1 and 3 are congruent, that means these lines are parallel. If you need help, please highlight angle 1 and angle 3, and you'll see what lines hopefully need to be parallel. There's only one set of parallel lines up there, and that's what? M and N are parallel. Is that enough to say a parallelogram? Can you just say one pair of sides parallel? Good enough? Nope, that's not good enough. I need both pairs, so that's not good enough. All right, what about 4 being congruent to 7? Those are what type? Alternate interior. 4, 7. Which lines would be parallel now? K and L, is that enough? No, I need both pair. I need both pair here. That's not good enough. All right, ready? 2 and 5. What type are those? Alternate interior, and that'll make, let's see, which lines there? K and L parallel. And then what if I had 5 and 7? What type of angles are 5 and 7? Corresponding, that makes M and N. Is that good enough? Both pairs of opposite sides parallel. Is that good enough? Yep. Why doesn't 4 work though? 3 congruent to 4 or what? Vertical. That tells me nothing about parallel lines, right? That tells me nothing. So that's the only one that's going to make it a parallelogram. See what you can do with 10 on your own. Okay, see what you can do with 10 on your own. It's a parallelogram. See if you can get to AFD. All right, opposite angles are congruent. That should get giving you 124 there. That's 124 is supplementary with the angle next to it, 56. This is isosceles, so that's 56. So 180 minus the 56s, we should end it up with 68 degrees for angle AFD. Okay, 68 degrees. I do not want to go the full class period, so I will pick up on rotating polygons Monday. I want you guys to start on the exam. And I just want to make a point here as you're getting out that exam. Eight problems from one exam covered these two topics. These are two monster topics on the Regents exam. All right, 8 out of the 35 are SOHCAHTOA and quadrilaterals. All right, so get going, get the January 24 one out and see how many you can complete.